It beats every second, every day, our whole lives, the heart. If it goes out of rhythm, a pacemaker is the last resort for millions of people. With this small battery-powered implant, heart patients can lead normal lives again. But it has a weakness. After 7 to 10 years, the pacemaker needs to be replaced because the battery life has ended. The surgical procedure used to fix the problem has some risks. It is not cheap and can cause fear. The best solution would be a battery that lasts forever and never fails. Researchers have been working on this problem since the 70s. One thing they have been looking at is a way to use the body to supply the energy. We all have an energy source within us, one that never runs out, sugar, specifically glucose. Each plate of spaghetti, each piece of chocolate, and each slice of bread that we eat replenishes our glucose reserves. The body converts the glucose into energy. This is the process that Philippe Cinquin and Serge Cosnier tap into. Similar to when you ride a bike, you move with just the energy on your muscles. The two Frenchmen are seeking to gain energy from these natural resources contained within the human body. We take energy from glucose in a way very similar to nature. Nature extracts electrons from glucose and passes them to the oxygen atoms. And this is exactly what we do in our biofuel cell. Unfortunately, we are not as efficient as nature. This tiny biofuel cell could supply implants such as pacemakers with energy produced by the body. As a foreign object, however, it also faces certain dangers. If you are not careful, certain proteins, which are also found in the body, stick to the biofuel cell. This decreases its efficiency. Glucose can no longer be absorbed, and the glucose-powered biofuel cell loses power. In the shadow of the Alps at Joseph Fourier University in Grenoble, Serge Cosnier and Philippe Cinquin's team got one step closer to solving this problem. They developed defense mechanisms to combat contamination by proteins, and another to prevent the biofuel cell from being rejected. So we designed a special semi-permeable membrane, which we glue onto the surface of the electrodes. And this membrane lets glucose and oxygen in, but stops the permeation of the proteins. So the final product is this biofuel cell, covered with a membrane, and the whole package is wrapped in a Dacron bag, which is perfectly biocompatible. It also prevents inflammatory reactions. In addition, the researchers have increased the performance of their glucose fuel cell. A special arrangement of the enzymes on the electrodes allows for virtually unlimited life of the fuel cell. Here we are coating the face of the electrodes with carbon nanotubes. Then we make a polymer and irradiate it to graft the enzymes onto the carbon nanotube. And so we have more enzymes on the face of the electrodes. And in this way we have more powerful biofuel cells. The Frenchmen are the first to implant a biofuel cell in a mammal, recreated here with an experimental arrangement. It was a huge success, which showed that the cell works in a living organism. This experiment proves that our biofuel cell works and produces sufficient power for a pacemaker, even a wireless pacemaker. This is a real revolution which requires energy scavenging. Now it's only a matter of time before this new kind of pacemaker with a biofuel cell is implanted into the first people. For this idea, the researchers have been nominated for the European Inventor Award.
For
me, it is a great pleasure to be nominated because I am the president of the French group for bioelectrochemistry. It is a great recognition for this area of research. For me, it is a dream come true, because I can see that the results of my research have potential to make a great impact on patients. This makes me very happy. We will see if the French researchers end up with this year's European Inventor Award, one of the highest awards for scientists, at the awards ceremony in Berlin. Their research in Grenoble goes on. The biofuel needs to be more powerful, so that they will be able to supply power to artificial organs of the future and bladder or insulin pumps. Someday, these scientists will conquer even this mountaintop.